we are looking at the second page of this proofs with segment and angle relationships. Again, we're going to start off with our given. And that was a typo there. Above that AT, it just says AT. We're going to draw in the symbol for array AT. And then we're going to put the measure of angle MAT equals 5x plus 10. I'm just literally copying down everything that's up here in the given. Measure of angle MAH equals negative 2x plus 68, and we're going to call all that just given. Given is always the first line. Just like our other problems we have, it's best to draw a picture to help you kind of process what we're talking about here. I don't know how big this angle is, so I'm just trying to draw one just big enough I can write my numbers and letters in here. It says MAH is bisected by AT. And then I'm going to put in the numbers they gave me. MAT is 5x plus 10. And MAH is this whole angle. And that would be negative 2x plus 68. So, alright, I know I got to solve for x if I'm going to find an angle. So we got to decide, how are we going to solve for x? So a couple things you need to know here. You can choose which way to start. Do we want to start by what does it mean to be bisected? Do we want to start with angle addition here? It's really up to you how you want to start this problem. So I'm just going to start with the word bisected. So if that angle is bisected, I know that the measure of angle MAT should be equal to the measure of angle TAH. That's definition, and I'm just going to abbreviate the word definition to DEF. Definition of, I'm going to call this an angle bisector. And here's why, because the key word up here is bisected. And you look at, okay, what was bisected? We were talking about angles, so it's an angle bisector. Okay? So, we know that MAT was 5x plus 10. So, I'm going to say the measure of angle TAH should also be 5x plus 10. This is what we call the transitive property. What the transitive property means is if I have MAT is equal to 5x plus 10, and MAT is equal to TAH, the transitive property says if these two things are both equal to the same thing, these have to be equal. That's called the transitive property. Okay? Alright, well I haven't solved anything yet, so we still got some more to go. Now in the picture, I know that this is 5x plus 10. Okay? Because I said that in my proof. I said that those two angles are equal, so I know that angle is 5x plus 10. So I'm going to choose now to do angle addition. I say the measure of angle MAT plus the measure of angle TAH equals the measure of angle MAH. It's a weird M, but sorry about that. We're going to call it angle addition. Now we're going to substitute in our numbers and solve. choose however you want to solve this. I'm going to combine like terms and get 10x plus 20. The thing about proofs, they seem long because you're writing every step you do out and you're explaining it. So like I would call that I simplified the left hand side. I'm going to add my 2x over to this side and get 12x. Addition, I was adding. Now the next step, I'm going to subtract the 20 to the other side. When you subtract 68 minus 20 is 48. This is called subtraction. And I'm going to divide and get x equals 4. That up a little bit. As you can see, I'm getting kind of off on my line, so that's why I number them, that this side to go with that side. So if my lines get a little off, it's okay. It wants us to prove that angle MAT is 30. So I need to plug x equals 4 back into MAT. Was 5 times 4 plus 10. And some people do this in all in one step. I call that step substitution. I showed just plugging that 4 in, and then my last step, when I'm actually going to figure out what that is, that's 20 plus 10 is 30. So that is just simplifying that side. Okay, so long. This is the longest kind you have when you have like a bisector or midpoint, and you have angle addition or segment addition, and you still have to solve it all. So that's the longest type you usually have. Alright, this next example takes it away from, now we're not going to do some algebra in it, we're just going to literally just talk about segments and angles without any numbers involved. So I'm going to give you a picture for this one. It wasn't drawn on your paper, but this is the picture you need for this. You're going to have a segment PQS and TQU. Okay, so given that information, the first line is always your given. So all proofs start off the same. We want that to be on the first line. So the next one on here is a definition, and for some of you guys that are doing this at home, it's the last page. If you scroll to the last page of the notes, you will find a paper that looks like this. And I've written some of the things on there. This is like some helpful hints with segment proofs. These are like some choices you may use. And then here's some helpful hints like on angle proofs, some helpful things you might want to use. So with this one, right here, definition of congruence. Definition of congruence says if two things are congruent, then we know they're equal. Or if two things are equal, then we know that's congruent. So that's just what the word congruent means. So looking back at this problem, the PQ and the TQ are still PQ and TQ. The only difference between the given and this line is these congruent symbols that were supposed to be congruent symbols, and I guess that program didn't have the congruent symbol. So to go from a congruent symbol to an equal sign, that's called definition of congruence. So let's see if I marked that in our picture, what that would look like. PQ is congruent to TQ, and UQ is congruent to QS. And I marked them different because we don't know that PQ and QS are the same. We just know these two are the same and those two are the same. So then they wrote out PQ plus QS equals PS. What is that called when you take a segment plus a segment? It's called segment addition. The same thing is true on this segment. They said TQ plus QUQ equals TU. So that's called segment addition. So let's see, what did they do here? This is the same, this is the same, but it looks like they replaced the PQ with the TQ. Why can you replace those two things? It's because on line 2 it says PQ equals TQ. So if those are equal, then you can substitute that in. So same thing here, they kept the TQ, but they changed the UQ to QS. Again, they substituted in this letters for that letter. Okay. So now, by transitive property, we can say, if you look at this, TQ plus QS equals PS, and TQ plus QS equals TU, if these two things are both equal to the same thing, then I know PS is equal to TU. That's called transitive property. I'm going to highlight that. If you see this and this is exactly the same, therefore those two things have to be equal. Again, this when I copied this, I didn't put that little mark there. So the definition of congruence, they're saying now PS is congruent to TU. So to go from an equal sign to a congruent sign, or congruent sign to an equal sign, those are both called definition of congruence.